We have a situation where the projectile is being thrown from a height. We know the initial velocity, 6 meters per second. We know the angle from horizontal, it's 30 degrees. And it's thrown from a cliff with 40-meter height. We are trying to find the maximum height and the distance that it strikes the ground from the base of the cliff. We'll draw a sketch first. This is the cliff. This is what the thrown trajectory would look like. We know that angle is 30 degrees from horizontal and it's 6 meters per second initial velocity. Let's write those down. Now, working with projectile, we always resolve the component of the velocity in the x and y direction. We'll do that. So Vx would be 6 cos 30, which is 5.2, and Vy is 6 sine 30, which is 3 meters per second. Now, we show the height of the cliff here as well. I assume that the starting point is A, the highest point is B, and the point where it strikes the ground is C. To do the first part, maximum height. Maximum height happens at B. So for now, let's talk about the journey of the stone from A to B. I am not worried about what happens after B. I am only talking about this path, A to B. When we do A to B, A is the initial point, so the velocity at A would be initial velocity. I am talking about height, which is the distance in the y direction. So I will only worry about y component of the velocity, which is 3 meters per second. So initial y component of velocity at A is 3, and final velocity at B, the y component of velocity at B would be 0 because B is the highest point. We know this equation, V final equals V initial plus AT, where A is the acceleration, in this case minus 9.8 meters per second square. We plug in the values. It's a simple equation. I will bring 9.8t on the other side of the equal sign, and now divide both sides by 9.8. You get t equals 3 divided by 9.8, which is 0.3 seconds. So now we know that it takes the stone 0.3 seconds to go from point A to point B. Now let's find out what is the displacement of the stone in y direction in 0.3 seconds. From A to B, we know the equation d equals V initial t plus half AT square. We have V initial 3, t is 0.3, A is minus 9.8. Displacement in y, that's what we are trying to calculate. We plug in the numbers, and this is our first line. Use the calculator to solve. It should be pretty straightforward. We get 0.46 meters. So the height from A to B is 0.46 meters, this height. When the question talks about maximum height, it usually refers to the height from the ground. So to find the height from the ground, all we do is add the height of the cliff, 40 meters. So the total height would be 0.46 plus 40 meters. 40.46 meters is the answer. Now for the second part, how far from the base of the cliff will the stone strike the ground? The base of the cliff is right here underneath A, and we are trying to find the distance of this point from C, where it strikes the ground. I'll work here. Now we are concerned from the journey of the stone from A to C. Again, the displacement here is minus 40 meters because we are talking about displacement in y direction from A to C, and C is minus 40 meters below A. The stone is traveling downward 40 meters to reach point C. So the displacement is minus 40 meters. We know this equation again. Displacement equals VIT plus half AT square. V initial is the velocity at A, which is 3. A is minus 9.8. We don't know the time. So when we plug in the values, we get this line here. Half times minus 9.8 is minus 4.9. We can bring everything on the left side of the equal sign, and now it becomes a quadratic equation. Use the quadratic formula. You get t equals 3.2 seconds. That means it takes 3.2 seconds for the stone to go from point A to point C. That's the time of flight. And now we are trying to calculate the horizontal displacement, which is dx. Dx has a simple formula, Vx multiplied by time, and Vx is 5.2. T is now 3.2. We multiply them both and we get 16.64 meters. That's your answer again for the second part. Hopefully it was clear. If you understand this, can you try the same problem but use the angle 45 degrees and the initial velocity of 10 meters per second and the height of the cliff as 60 meters. Do the math and let me know your answer in the comments below.